This is Peer Teach problem B. Make sure you make your classmates work for the answer. Make them finger track and read out loud. Ask leading questions about, like, what do you know about this shape? Guide the conversation. Do not give answers. Taking a look here, it says, in the rhombus below, stop. Ask the person everything they know about a rhombus. Why don't you try to mark as fast as I do? Mark everything you know is true about a rhombus on the diagram right now. We know all four sides are equal. That's the definition of a rhombus. We also know that these corner angles get bisected. We also know that there's an angle in the middle. These are the things we know about a rhombus, and of course that the opposite sides are parallel. Now let's put our information on here. We know BD, let's trace it, is 12. And since it's bisected, I'm instantly going to break that down to 6 and 6. A to C is 16. I'm instantly going to break that down to 8 and 8. And that's all we're given, folks. We have ourselves a rhombus with these lengths, and we're supposed to find all side lengths and angles. I'd like you to physically shade this one triangle right here, and let's pull it out. You should notice that we have a right triangle going on here. Remember all that right triangle stuff? 6, 8. Let's go for the easy thing first. And the easy thing is we could easily find this third side. Say it with me if you remember. If you have two sides and you need a third side, tag. Say it again. If you have two sides and you need a third side, tag. Let's write our Pythagorean theorem equation down. Now let's circle plug Chuck. You solve your math, try to beat me. You should be able to, since I'm doing mine in multiple colors. All right, we just found our side length here was 10. Easy thing about rhombus is all equal sides. We established that earlier. Okay, it looks like everything is found, but wait, there's more. We have all the angles to find, but the wonderful thing about a rhombus, all you need to find is one measly corner angle. That's it, folks. And I'll show you how to do that. Okay, so that's going to be our theta right there that we're going to work with. So let's work with that. And now from there, let's establish our opposite. That's the theta we're going to work with. We just found that that's 10. Now that we have our opposite, our adjacent, and our hypo, we could use any one of the inverse sign inverse cosine, or inverse tangent. Any one of these would work if you have all three sides. You don't have to use all three of them. Choose whatever makes sense to you. This time, I'm just going to work with the original two numbers, the 6 and the 8, which would be opposite and adjacent. So that's OA. I'm going to use tangent. So my opposite of that angle there was a 6, and my adjacent is an 8. So I'm going to use inverse tan, 6 over 8. You try it on your calculator and see if it matches with mine. You're going to round to the nearest whole degree. In this case, I have 36.8. So it's approximately 37 degrees. Now we can come back up here, and if that's 37 degrees, once you have one angle, look, it is so easy. We have ourselves a bisector here. So that's 37. Opposite angles are equal, so that's 37, and that's 37. Triangles, folks, add up to 180 degrees. So I'm going to add 37 and 90. I'm going to take that away from 180. And I figured out that this is 53 degrees. Again, diagonals bisect the corners. Also, opposite angles are equal because it's also a parallelogram. Looky there, folks. Now we have found all segments and angles. Make sure you're able to explain this to your classmate.